Good morning, everyone. Thank you for joining us. My name is Mary Carlson. I'm with Kimley Horn, and I'm chair of the CTS Planning and Economy Research Council. Welcome to our webinar this morning and council meeting. We are recording this event and will post the video recording to the event page so that anyone can view it after today's event. We will also be posting the presentation slides. We're joined today by Vice Chair Lisa Austin. Lisa, would you like to introduce yourself?
Yes, thank you, Mary. I'm Lisa Austin with MnDOT. I've been with MnDOT for about 12 years. I'm currently working in the Center for Community Connections. I've been a member of the council for about, well, probably since I started at MnDOT and overseeing several research projects through MnDOT. I'm really pleased to be taking a leadership role on the council and look forward to being part of these going forward. So thanks a lot, Mary.
Thank you so much for joining us, Lisa. It's so great to have you. As everybody knows on this call, or many of you know, CTS councils provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. We bring together university faculty and staff with practitioners from both the public and the private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. Katie will put a link to more information in our chat box if you would like to learn more information about our councils. Today's meeting, we are featuring a presentation from University of Minnesota researcher and Portland University researcher on the innovative strategies for last mile delivery in urban areas. Following the presentation, we'll hear from Andrew Andrusko, MnDOT's Freight Planning Director, who will provide an update on MnDOT freight initiatives. And we'll also have a round robin hearing from all of you. So start thinking now about what you want to share with us as a group. At this time, I'll turn it over to Gina, who will share some housekeeping tips for us.
Well, good morning, everyone. I'm Gina Boss, the Associate Director for Engagement and Education at the Center for Transportation Studies. So great to see such a good turnout today for what's going to be a really interesting topic, I think. So let me just get these housekeeping items out of the way so we can move ahead. We will, following Alireza and Miguel's presentations, we will have a time for Q&A. And so we'll ask you to either use the chat or the Q&A feature to ask your questions, and we'll be facilitating those for the speakers. Then following Andrew's presentation, we will have an opportunity for a round robin, so you can share what's going on with your organization as we move, or currently activities that are going on that might be of interest to this council. So what we'd like you to do is just in the chat tap "I'd like to," or type "I'd like to share," and we will unmute you so that you can give your update verbally. You won't be using the video, but you will be able to introduce yourself and speak and give your own update. Finally, I want to mention that for credit, we are offering credits both for engineers and for planners. So this webinar does meet requirements for 1.75 PDHs and 1.75 AICP continuing maintenance credits. And we have been notified by AICP that this is, it has qualified. So for planners, you'll need to go to the website, or you need to take care of that on your own. For engineering folks who would like their certificate indicating of participation, type into the chat box just to panelists, not to everyone, that your name and your email address indicating that you'd like to have a PDH form sent to you. So next, as we move into this sort of fall season, we have a new chair or vice chair, Lisa Austin, and we're so excited about that. But I didn't want to let this opportunity to go by to say thank you to our previous chair, Jonathan Ehrlich, who has served both as chair and vice chair for the Transportation Planning and Economy Council for the last 6 years. So I have a plaque. Whoops, can't see it very well. There we go. We have a plaque for Jonathan from the university that says, "In appreciation of dedicated service," presented to Jonathan Ehrlich, Transportation Planning and Economy Council Chair 2017 to 2020 and Vice Chair 2015 to 2017. And on behalf of CTS, I just really want to thank Jonathan for his service as the Vice Chair and Chair for this council, and just in general for Jonathan's support of CTS and for university research. He's served on numerous technical advisory panels and been a TL, and he's always willing to volunteer and to help. He oftentimes provides data and other types of information for projects, and consults with faculty and researchers, and we just so appreciate his engagement. And we know that just because he's no longer chair, that Jonathan will stay engaged and connected to the university and to CTS, and we just really appreciate that. So with that, I'd like to invite Jonathan, if he has anything that he would like to say at this time, to go ahead and do that.
Thank you very much, Gina. That's a very generous praise. And I just wanted to compliment the work of CTS and the council's ability and the of researchers and practitioners to connect over this forum is one of the incredibly valuable things that CTS does. It's been tremendously helpful to me, and it's been very gratifying to be involved in both participating in such great research and in helping to disseminate it to the broader community. So I'm really excited about that continuing to happen, and I'll continue to be involved, of course.
Great, thanks, Jonathan. And I'll have to figure out how to get you your plaque. So we'll get that taken care of. At this time, I would like to introduce John Hordos, who is the director of the Minnesota Traffic Observatory and also serves as the research director for the Freight Mobility Research Institute, which is a multi-university consortium that is focused on freight issues. And our speakers today are members of that consortium. So I'll turn it over to John.
Thank you, Gina. First, I would like to thank the members of the CTS, Transportation Planning and the Economy Council for the invitation and interest in the research efforts supported by the Freight Mobility Research Institute, FMRI for short. As Gina already mentioned, the FMRI is a Tier 1 University Transportation Center funded by USDOT in 2016, and we're going through our fourth research cycle right now, and we have one more official year, hopefully more. The FMRI, led by Florida Atlantic University, is a collaboration of faculty, researchers, and students from FAU, the University of Minnesota, Portland State University, University of Memphis, University of Florida, Texas A&M University, and Hampton University. We're a big group, but we kind of like it that way. The FMRI's mission, as Gina pointed out, is to strengthen our nation's economic competitiveness by embracing innovative research projects in order to create efficient and safe freight systems, train current and future transportation leaders and workforce, and to engage with industry to enhance collaboration between agencies. The FMRI's research goals are to improve freight mobility through information technology, freight network modeling and operations, intermodal logistics, as well as freight and supply chain sustainability. This collaborative research aims to promote smart cities, improve multimodal connections, system integration and security, data modeling and analytical tools for optimizing freight movements. So I just wanted to give everybody a little introduction on the FMRI. I'm gonna shut up now and let Dr. Scani and Figliosi have their presentation. If you have any more questions or interest on the FMRI, you feel free to contact me. Thank you very much.
Great.
Thanks.
Go ahead,
Thank
Mary.
you so much, John. That was a great introduction. And thank you to both you and Jonathan for both your leadership on this council and obviously in our industry as well. We want to welcome all of you and your colleagues, in addition to joining us for our webinar today, to join us for upcoming webinars. You see that we have some really great ones coming, including Smart Cloud Commuting Service, as well as Reducing Minnesota's Transportation Carbon Footprint. So those are October 20th and October 27th, and feel free to register at the link on the slide for those upcoming webinars. And then in November, we have our annual research conference, and we are going all virtual this year. That being said, don't shy away from it. I've been participating in some all virtual conferences, and they have been fantastic. And I know that our CTS conference will be fantastic this year. So again, that's November 5th from 8:30 to 4:30 all day. And then more information is on the slide, as well as the link to register. So please join us. As we move into today's presentation, just want to give a little bit of an introduction. As many of us know, especially those of us who are still working from home, in the last decade, online shopping has realized double-digit growth annually. This has led to greater demand for package delivery and new last-mile transportation issues related to curbside management, especially for municipalities. The researchers that you'll hear from today are studying issues related to last-mile delivery in urban areas, particularly the advantages of using innovative methods, such as delivery robots and shared lockers. They'll review a study exploring the regulation, performance, cost, and environmental trade-offs of delivery robots. They'll also offer an overview of research related to shared lockers, including the development of a model designed to optimize their location, and the routing of delivery trucks and assignments to customers to each locker in order to minimize the traffic impacts of last-mile delivery. Our speakers this morning are Alireza Khani and Miguel Figlioso. Alireza Khani is an assistant professor in the Department of Civil, Environmental, and Geoengineering here at the University of Minnesota. His expertise is on modeling and optimization of transportation networks with application to transit, shared mobility, and freight. And Miguel Figliosi is a professor of civil and environmental engineering at Portland State University. His expertise is on transportation system analysis and modeling. And as we said before, Miguel is a member of our Freight Mobility Research Institute. Welcome, Alireza and Miguel.
Thank you. Let me know if it's okay. Should I proceed with the presentation?
Go ahead.
Okay. Are you able to see my screen?
Yes.
Okay. Well, good morning, everybody. Thank you for attending this presentation. And as they mentioned already, I'll be happy to discuss and answer any questions at the end. I'm just going to give a very kind of brief and broad overview of some of the research we have been doing in the last 2 or 3 years. And this research has been supported by fMRI. So just as an introduction, I would like to say that, it was already mentioned that before COVID-19, there were already some important trends regarding e-commerce. The very, rapid increase, and during COVID, things became a bit more clear in terms of how rapid is this increase, and the changes also in demand patterns, and obviously this is affecting not just consumers but also the whole supply chain. And just to give you some numbers, you can see here, some impressive numbers, like compared to April-May 2019, sales were 7% over the holiday peak, meaning the holiday season, and 50% or more compared to a year ago. And Walmart, for example, increased 74% sales, and Amazon also, even though it's the biggest by far player in this area, it's having an impressive growth despite its market dominance. Then not only package delivery, but you should also consider that food grocery deliveries have also experienced a significant impact in terms of growth, and some numbers are, very impressive, 500% in April, year over year, compared to 2019. That kind of has, gone down a little bit, obviously, but still much higher than pre-COVID levels, and that's had huge impacts in terms of not only consumers but also this provider of services. They had to hire many more workers and reconfigure, scale up very quickly their operations in terms of hiring and deploying these services. So overall, at the beginning of the pandemic, there was a 300% growth on online food and beverage, and this was the fastest growing category. So that to say that didn't come, without any pain, and you might be familiar with the news in terms of issues, labor unrest. There were walkouts at Instacart, workers not being, satisfied in some cases with pay rates, not being, having change, or with some of the safety conditions. So there have been improvements since then, and this is a situation that, because it's growing so fast, this sector of e-commerce, they keep hiring, and there is, it's the labor and the human side. It's a very important one. I'm not going to focus too much on that, but I think it's a very important part of the context and the future of this industry. But it's also a segue in terms of why also many companies are thinking about automated vehicles and automated services. It's not just robots in warehouses, but also robots that can deliver to customers. And I'm showing in the screen here two different types, what we call them autonomous, could be ground delivery robots or ADRs. And basically they deliver to customers, no delivery person, meaning there is no one really going with the vehicle, though there is obviously some remote monitoring of these vehicles, and they can travel on the sidewalks or on the roads. And the vehicles are very different, and as well as the regulation that kind of they have to operate. So obviously there is a picture here, and you can see that the size of the Starship is one of the most common you see in the news. This is kind of one of the companies that have been pushing very hard this type of technology. And on the other, at the bottom, you see two other vehicles. One is the Neuro, the other is the UDEL. And some have been adapted, like standard vans that have been adapted to be autonomous, and the other case is a vehicle that has been designed from the scratch to be an autonomous delivery vehicle. I'll talk a little bit more later about payload speeds and ranges. So in terms of the sidewalk delivery vehicles, because they tend to be small and they don't have a very a long range, they have to be, in many cases, they have been designed to be, for example, partner up what it's called a mothership. And this is showing one picture where there is a vehicle that can store these vehicles, transport them, and then unload them at the location where they can serve and deliver to final customers. And again, this is still a human-driven van that has been adapted to this purpose. So there have been a lot of applications and changes in terms of these vehicles, and I'm showing also, COVID-related things started in China, and China also saw one of the first deployments of this type of vehicles to help with servicing retailers, hospitals, malls, and complexes, apartment complexes, in a way that is safer and reducing human interaction, and without close contact between people. And the same type of applications have been also used in the US, and here showing some tests that were done in California to carry food supplies and medical equipment between different facilities related to treating COVID patients. And that has also been used in Florida, and in this case they were using a Navia minibus for the purpose of, instead of carrying people, to carrying supplies and tests between different facilities. So just to kind of wrap up a little bit about the vehicles, it's just to say that this is a very fast changing landscape. And if you follow the news related to these vehicles, you see every month it looks like there is a new player or a new startup trying to come and start to provide services. But one of the most interesting one is the one that FedEx partnered with a company that also works in terms of wheelchairs, and they were able to come up with a vehicle that bigger, the tail you see is 200 pounds, the range 8 miles, and 100 pounds payload. But also, as you notice there, they have the small wheels that they have a very important capability, that is they're able to go up the stairs. And that's a very important issue to access many homes for them, kind of the last 50 feet of delivery. In many cases, you need to navigate terrain or sidewalks or stairs that are not easily traveled by the other vehicles you see on the right, that will have no option in terms of accessing really the last feet of the journey. So just a quick overview. We have, I'll mention later papers we have, and happy to share them where we talk more about these things. So just to give you, there is a lot of variation across cities and states, but some typical regulations for the sidewalk delivery robots. So typically there is obviously concern regarding safety, and the weight limit, it can vary, but in many cases up to 80 pounds, and a speed limit too, 10 miles per hour or even less in many cities. They have to follow pedestrian laws. They have to have insurance. They have to have headlights, especially to operate during nighttime, and they also have brakes. And basically they have to be safe enough to not harm any property, or obviously pets, or pedestrians, and that includes children and elderly and anyone that could be using the sidewalk. So for the road vehicles, they tend to follow, because there are road vehicles, they tend to follow the regulations that apply to autonomous vehicle, to what you might see that the typical autonomous vehicle, and obviously much higher insurance. Operators might have all the time supervising the vehicle, and some override features. But again, there is a huge variation in terms of different states and cities, and Arizona tends to be the one with the kind of more lax, more softer regulation, and places like San Francisco or bigger cities tend to be more conservative and be much more, have many more rules and safety precautions than what is currently being applied in Arizona. I also want to mention that it's not just ground vehicles, but probably you also heard about drone deliveries, and there is also a wide range of vehicles, and don't have the time to talk about all the particulars, but there is, you could have drones that are electric, you could have ones that are based on ICE or internal combustion engines, and they can be fixed wing or multi-copter. And I'm showing a picture there. It's a DHL German prototype, and the one below is the one with the fixed wing. And there is a big difference in terms of cost and performance and flexibility. Clearly, for urban applications, the fixed wing is not very flexible in terms of, to navigate poles and cables and buildings and obstacles. And even though it's better in terms of performance, speed, and range, the multi-copter is much more flexible and you can do the vertical takeoff and landing. And there is also regulation from FAA regarding drones, and there have been during COVID also some exceptions for deliveries of supplies. And this is one quote from a mayor in North Dakota, that they have been deploying these vehicles to to make deliveries to the population, and with good success. Just to give you a quick idea about what we're talking about in terms of transportation capabilities, and these are just some numbers that they're rounded for readability in terms of the table, but you have the vehicles. The Starship is the sidewalk delivery robot. The Neuro is an on-road design vehicle for on-road operations. The UDELV is another on-road delivery vehicle. Then you have the MD4, it's a German drone. And then you have the Renault EV, it's a typical European electric vehicle for urban deliveries. And the last row, you have a Dodge Ram, very typical vehicle used in urban areas. And you see in the first column, the third, just in terms of the size, the mass of the vehicles, you see that there is a huge range, with the drone and the Starship being, fairly, small compared to the, normal vehicles. And the same thing in terms of the speed of the sidewalk delivery robot. Obviously is low, designed to be low speed, again, and that's again related to the safety. And the other vehicles are, has fairly good speed capabilities. But when we go to payload, the sidewalk delivery robot is, 18 kilograms, but really that's where the drone tends to have the biggest kind of challenge in terms of being able to deliver significant payloads, because they're fairly, significantly limited in terms of their capabilities. In terms of range, again, electric vehicles and these electric delivery robots, they don't have a long range, and you see they are, in most cases below 100 kilometers. That's 60 miles, and in some cases even less. We're talking about 10 miles in case of the Neuro. And then the last column, it shows you the energy consumption. And again, for all these electric vehicles, that it relates to battery needs in terms of the size of the battery and how much of the weight is related to the battery. But you see that very low energy consumption for the drones and the sidewalk delivery vehicle. And that's also kind of important if you're thinking about CO2 emissions, in terms of all these electric vehicles tend to be, very clean and very kind of emissions friendly when you compare that to, to the emissions that would have a normal, delivery van that is diesel or gas. So we did a lot of research, but just to kind of summarize a little bit, some of the, in an easy kind of table, some of the kind of advantages of different vehicles. So if we are thinking, like, say, well, what would be the ideal fleet in terms of energy emissions? And we're just showing here one case, just thinking about the depot is close to the service area, or the depot is far from the service area. And here we are thinking about, this vehicle have to serve customers with some time constraints. So meaning, for example, they have to serve customers in an 8-hour time window, yeah? And then thinking about the density of the customers, high density, low density, and then you have all these different trade-offs. And in terms of energy emissions, the drone, for example, with low density and being close to the depot will be the best type of delivery vehicle. But if you have higher density, then the Neuro, that road delivery vehicle will be better because it can serve more customers per route. And we're talking about, when you have distance that is the depot is far from the service area, then the E-van will be the best vehicle for low density. And in some cases with high density, one of the road delivery vehicles would also be competitive. So that's focusing on emissions, but obviously for a successful and sustainable deployment, you also need to think about cost. And if you think about cost for low density and short delivery times, the conventional van would be the most convenient, the most cost-efficient vehicle when you have short delivery times and low density or high density. And in some cases, the drone, for example, could be competitive if you have long delivery time and you have long density. And in some cases, the on-road delivery vehicles could be competitive when you have high density. So these results are basically saying that most likely, given the current characteristics and technologies, it's hard to think that one type of technology is going to be best suited for all scenarios. Most likely, depending on the density, the distance from the depot, the customer demands, the payloads, there will be trade-offs, and most likely one or more of these technologies will have to be deployed. Just to kind of say that we focus on the kind of the transportation side, but there is also kind of the last yard of the delivery. And I'm not going to go into this, but there are many different ideas being proposed, from delivering to porches to mailboxes inside the home or car. So some of these robots can have electronic keys and be able to interact with the doors or gates to be able to enter and deliver. And the same thing with the storage locker. So again, I'm not gonna don't have time to go into too much detail, but just to give you that there are many options also and technologies being considered for the last yard of the delivery. So finally, I want to kind of convey that technology is not ready at scale to deploy, and that's including here some quotes from some CEOs and founders of these startups, in the sense that these vehicles are still slow, and in many cases when they encounter an obstacle, they need remote assistance, to be able to navigate the sidewalks or the streets. And it's something that they are really working on. But if you think about like 3 or 4 or 5 years ago, none of these vehicles were on being deployed. So they have been quite fast progress. So even though they are not ready, I think it's for people in the transportation planning and thinking about the future, is it's always very hard to forecast how fast technologies are going to improve or if they are going to mature, but they are advancing and making progress at very rapid pace. And again, COVID has been a very important catalyst, very important incentive to increase the funding and the number of companies that are working on this type of technologies. So just to wrap up a little bit, so there is we're I think in the middle of a we're changing the last landscape in terms of I think also in terms of from home working, and now freight and deliveries are being perceived as an essential service. And I think in terms of consumers too, I think there is they are being much more friendly to the adoption of these technologies. And there are different surveys that have been done, and there is a potentially very high approval rate in terms of consumers being open to try these type of services. And I think in terms of cities and states, we have also seen much more willingness to experiment, and with permits and space allocations, and to lift regulations in the case of drones or these autonomous vehicles, especially to deliver tests or medicines or to support COVID operations. So that the COVID has been, something that has been used to, in a way, to increase the experimentation in this area. And again, this is kind of, we're talking about still, short, medium term, but, there will be more realignments, in the longer term, and, still, they are still unfolding, and we are not sure exactly how it's gonna, look in the future. But what we think is this, is consolidation of trends in terms of e-commerce was growing very fast, before COVID, maybe at the 10-15% annual growth, but obviously with COVID, that has doubled or maybe triple, depending on the areas. And that, package and service deliveries, they have grown a lot, and very likely they continue to grow. So the emergence of and utilization of these vehicles is likely to continue and to be, more ubiquitous and frequent in the future. And again, the trend to automation is not just, again, in the transportation side, but if you follow the news in warehouses and all across the supply chain, there has been a big push to automate and to especially to be able to scale up operations quickly. And as I mentioned before, the issue related to labor issues has been, a very, very important issue for many of the companies operating in this area. So just to kind of bring it back to, again, this is related to remote working and brick and mortar shopping that has been, again, has experienced substantial changes, labor and health issues, more investments, like I mentioned, in contactless technologies and automation, and cities kind of thinking about reallocating road and curb space. I'm just going to quickly mention some, ongoing and open questions. So we have done some surveys during COVID to kind of gauge the number of how deliveries have changed before and after COVID. And so we plan to continue with these surveys to see what are the factors driving deliveries and delivery rates at households. And this is something ongoing, and still, we have some preliminary results. I'm happy to talk about it. But the second part of that would be to, also kind of think about how is this translating in terms of more or less traffic, or, how trips are being, saved, or how, in terms of vehicle miles, how is this affecting the overall traffic picture, and what percentage of traffic is related to this type of services. The third thing is like equity impacts, and from the results we have seen, and from our survey, it's kind of important to think about who is benefiting and who is having access to these services and technologies. So at least from our preliminary results in the Portland area in Oregon, we don't see that, is that everybody's benefiting at the same rate from this type of home deliveries and package and food deliveries and so on. And finally, we're also kind of tackling in another project this idea about how to value and allocate roadway and curb space, because it's still, you know, if this continues to grow and, you know, there is competition for a space, what is the right price, or what is the right, you know, way to allocate a space in a way that is fair and to seem to serve, you know, customers, people in the most efficient way. So here have some publications, and again, I'm happy to share more of them later if anyone is interested. And I need to acknowledge some researchers, and Dylan Jennings, one student working in our Transportation Technology and People Lab at PSU, and of course the research, all the research that I have overviewed and ongoing research has been funded by FMRI. And with that, I would like to, you know, close, but like I said at the beginning, I apologize if this was a very fast-paced and kind of broad overview, but I'm happy to provide more details later if anyone has any questions. Thank you.
Okay, I guess it's my turn. I'm going to share my screen. Do you see my screen now?
Yes, we can see your screen, Alireza.
Yeah.
Okay, thank you. Okay. Again, I'm Alireza Khani. I'm going to turn off my video just because of the internet connectivity. Thank you for the opportunity to present my research. Thanks to CTS and the council for having us. I'm going to talk about some of the preliminary findings from my ongoing project funded by FMRI. This is actually a joint project with Professor Miguel Figliotti at Portland State University, and we are working on some related aspects of last mile delivery. With the great and fantastic overview of the last mile delivery methods by Miguel, I'm going to transition to something more focused on shared locker system and presenting a decision tool basically that can optimize the planning and operation of the shared lockers for the benefit of the system. So I'm going to skip some of the introductions because Miguel provided a very nice introduction of the growth of the e-commerce and last mile package delivery. And then I'm going to talk quickly about the optimization method. I promise it's very high level, not much math. And then I'll show you some results from a case study in downtown Minneapolis. So of course, yeah, there's great increase in e-commerce and last mile package delivery. Just shortly, even before the COVID pandemic, 82% of Americans have been e-shoppers. They have done it at some point. And 16% of US retail sale has been online. And it means 16 billion packages delivered in 2019. That's a very large number, and it requires huge operations of last mile delivery trucks or other methods. And there are some studies, for example, one in the UK that shows that in the past 20 years, there has been a steady growth in good delivery vehicles and in the truck kilometers on UK roads. And also in Germany, there have been some studies that showed how truck operations impacts the traffic in terms of how much do the delivery trucks usually stop on the curbside or block the lane close to the curb, and how much they interrupt the traffic. And the biggest interruption has been affecting modes other than cars. For example, transit vehicles have been interrupted by delivery trucks, and very importantly, bicyclists and scooters and sometimes pedestrians have been impacted by the stopping trucks to deliver the goods. And the disturbance of the traffic varies across different land use types. For example, in downtown areas and the mixed-use land use, the length of the truck stopping time is usually longer and there is a greater impact to traffic. But in commercial and industrial area, usually that impact is less severe. The big challenge in last mile delivery is that many people prefer home delivery of their packages. A study by UPS in 2015 shows that 2/3 of people prefer home delivery as opposed to other modes of delivery, for example, to the UPS store, post offices, etc., or to workplaces, etc. They prefer to have their package delivered to their home. But home delivery is very costly and inefficient for several reasons, including the operation of trucks to visit every single house, and also failure of the delivery, for example, because there's no one at home to receive the packages, or the item could not be left at the house, at the door. So for this reason, home delivery is less efficient mode of last mile delivery. And in the last few years, there have been an emergence of different last mile delivery modes. Very briefly, I have 3 types of them listed here. Collection and delivery points, these are the facilities that exist in some neighborhoods, for example, within a distance from customers' homes. And packages are kept there and people can go pick up their packages from there. The downside of the CDP's, collection and delivery points, is that these places need a staff. It's operated by a staff, and of course it's more costly, and also it has a limited operating hours, so people have to visit these places to pick up their packages within the certain hours of the day. An alternative is shared lockers. These lockers are independently located at some places, some more accessible locations and more strategic locations with high foot traffic. And customers receive a digital code and they can go open the locker and pick up their package from the locker. And we have seen some of them, for example, Amazon locker at grocery store, at Whole Foods store, and similarly by other companies. And the other mode of last mile delivery is by robots and drones, and Miguel gave a very nice introduction of those items. So I'm going to talk or focus on shared lockers now and present a decision tool that can optimize the planning and operations of the shared lockers, and see how we can gain the maximum benefit to the system. So let me introduce the problem. There's a little bit engineering here, but again, I'm going to explain it in a very high level. Assuming that we have a road network of a city, for example, or a downtown area, and we have a customer demand points, the residents, for example, or the businesses to which we need to deliver the packages. We want to know where we should put these packages in that area such that the overall system cost is minimized. On this figure, I'm schematically showing that we have a few demand points, these little circles, and we have a distribution center. We want to know out of a few candidate location, which location should be selected for setting up a shared locker. And simultaneously, how should the truck be routed to deliver the packages to customers or to the shared lockers and more efficiently. One note here is that with shared lockers, a truck can have a blended route, which means that the truck can deliver the package to some of the customers at home if the location is on the way. And it can at the same time deliver some of the packages at the shared locker, and some of the customers can go and pick up their packages from the shared locker. So another decision is to assign the customers to the shared lockers. So again, in summary, we have three decisions. One is to where should we put these shared lockers in our network? Second decision is how should we route the trucks optimally to reduce the truck mileage in our network? And the third decision is that how we should assign the customers to the shared lockers optimally. And the objective is to minimize the total system cost. I'm going to explain the objective. So the objective has three terms. The first term is the company's delivery cost. This is basically the truck mileage of the last mile operation. We want to minimize it because the cost of delivering packages is proportional with the truck mileage or truck operations. In a traditional home delivery, we want to minimize that truck routing, mileage, or hours of operations. And this can be viewed from two perspectives. One perspective is from the company's perspective. They want to make their operation more efficient. But from the public perspective and from the society's perspective, less truck mileage means less impact on traffic, less air pollution, less fuel consumption, and possibly better safety. So if we can minimize the truck mileage, the society can benefit from that. The second term in the objective is the customer's pickup cost saving. And this can be compared with the truck operation again. So for example, if a customer can be served by a shared locker and that customer can just walk to a shared locker to pick up the package, as opposed to the truck going to their home address and delivering a truck, there will be some saving for the system because there will be, again, less truck mileage and all the consequences or the positive effects of less truck mileage. There is one and only one mathematical symbol that I want to mention, and this is parameter gamma here. This is the ratio of a customer pickup cost to the delivery truck cost. And it means that, for example, instead of having 1 mile of a truck on the road, if we can have 1 mile of personal vehicle, there will be less impact on traffic, and this gamma represents that ratio. Or if the customer can just walk to a shared locker or take transit or scooter to a shared locker to pick up the package, there will be saving for the system because there will be a reduction in the truck mileage. And by changing this value of gamma, we can see how the system can gain some efficiency. And the last term in the objective is the capital cost of setting up these lockers at some locations. So again, in summary, we have the company's delivery cost due to truck operation, customers pickup cost saving, and again, this is saving, the opposite of the cost. And the third term is the lockers capital cost. So there's complex math here. I'm not going to talk about this, but just want to acknowledge that there has been a great engineering work behind it. And now I'm going to talk about the case study. We tested this decision tool on downtown Minneapolis network. This is an area that we selected between Washington Avenue and 10th Street, I believe, and between Hennepin and Chicago Avenue. We assume that there is a demand for package delivery at every block corner. One key point here is that I want to mention that we communicated with the city of Minneapolis and other public agencies, and we did a lot of search to find a good demand measure for package delivery. But unfortunately, there seems not to be a good demand data publicly available, so we can do our research and planning and decision making. Therefore, we assume that there is a uniform demand and randomly distributed in the network. we made some other assumptions. For example, we have 2 delivery trucks, we have 12 candidate locations in the network, and we want to select some of them. And we do some sensitivity analysis to see how much savings we can gain by using shared lockers as opposed to home delivery. Here I'm showing 4 scenarios. And in each scenario, I assume a different customer pickup saving. On the top left, the value of gamma is the largest that we selected, 0.5. And in this case, it means that there is less saving by customer picking up a package from a shared locker. And in this case, our optimal decision is to have the trucks deliver all the packages at the destination or the demand points. The blue lines here show that show the truck route, and we see that all the blocks in the downtown area in the network are visited by the trucks. So there is more truck mileage basically here. When we have a smaller value of gamma, which means that greater saving by customer using the lockers, on the top right scenario, we have a little less truck mileage on the network, and one shared locker is open and a few customers are assigned to them. And we see that the optimal cost has reduced from 27.2 to 26.9 units. Continuing this reduction of parameter gamma to 0.3 and 0.25, we see that actually the truck mileage on the network is even further reducing. In the bottom right scenario, we have definitely less truck routing on the network, which means less truck traffic and less fuel consumption, less air pollution. And 4 shared lockers are selected on the network, and several of the customers are assigned to these shared lockers. And comparing the operation, the optimal cost, we have 22 versus 27 in the baseline scenario. I'm summarizing this in this graph now. This should be very straightforward. On the x-axis, we have parameter gamma, again showing the customer pickup cost saving versus home delivery by truck. And by having a small parameter for gamma, a small value for parameter gamma, we have a greater cost saving. And this is, again, the system cost saving. This is not just for the delivery company, but also this is for the society. And this cost saving can be as high as 19%, as opposed to the baseline scenario, which is gamma equal to 0.5 and basically no saving due to shared lockers. I have a very interesting scenario here I want to talk about. In this case, we take into account the possibility that people use different modes of transportation for picking up their package from a shared locker. We assume that if the distance between the customer point and the shared locker is less than 500 meters, people can potentially walk and pick up their package. So the parameter gamma is small for any distance less than 500 meters. For larger distances, we have a larger value of gamma. For anything greater than 2 kilometers, customers are likely to have to plan for their trip and use their car to go and pick up their packages. Therefore, there should be a larger gamma value. When we run this scenario, we actually get a much greater saving in the optimal cost, because not only those customers within the 500-meter radius are assigned to the shared locker, but also some customers outside that are assigned to the shared lockers. And this means that when there is a market for a shared locker, demand market, not only that market can help the system to gain some benefit, but also it brings up the opportunity that other markets, for example, people living in outside that market, can also benefit from the shared locker, and the whole system can benefit from it. In other words, there is economy of scale in this case, and the system can benefit from the economy of scale. And this is the last graph that I have on my slides. Another analysis is the system cost saving with respect to capital cost of setting up these lockers. All the results so far was based on 300 units of cost for setting up a shared locker. But now we change it to less than 300 and more than 300, from 200 to 400. And we see that when the cost of setting up these lockers is less, there is a greater saving for the system. And it can go all the way to 28% in our tested scenarios. So what it suggests is that if there is an opportunity and some support to setting up this innovative last mile delivery, in other words, shared lockers, the system will benefit from this. The society will benefit from this. This could potentially suggest that public agencies could provide some opportunity for companies to set up their lockers, some incentives for them to set up their lockers, because it's not just the delivery company that benefits from it. It's the society that can potentially benefit from this. So in summary, we developed a decision support tool that can simultaneously select the optimal shared locker locations, develop a truck routing, and do the customer assignment to minimize the total system cost. And we show that in our tested scenarios, of course, with some uncalibrated parameters because of the lack of data, with sensitivity analysis, we showed that the cost saving can be from 19 to 28%. I'm going to talk about some of the future work because this is an ongoing project and we have encountered some challenges and some really interesting ideas and opportunities for continuing this work. From the modeling perspective, one issue is that the package delivery demand is uncertain. It's not fixed from day to day, and it's not fixed during different seasons. Because of the holidays, we may have different level of demand. COVID, of course, increased the demand significantly. And we want to make sure that this uncertain demand is captured in our decision tool so that we can have a robust decision for locker location and truck routings. So in a worst case, the system would not be severely impacted. Another point is that we assumed in this case that customers can accept the decision that they have to go pick up their package from the locker. But in reality, people may have different choices and preferences. And we're working actually to capture the user choices in the model. And another extension of the model could be on incentivizing the customers to use the lockers. And this is something that I'm sure companies are working on and we are interested in working on too. Sometimes by providing a little discount to a customer, they may be incentivized to accept a package delivery to a shared locker. But the system can significantly benefit from that by reduced truck mileage. So this could be some interesting research to work on. In terms of the benefit of this research or the future steps of this research to inform practice and policy, I think very interesting and important point is that, as I mentioned before, customers may have different choices and preferences. And from the perspective of public agencies, I think it will be important to understand customers' choices and where there is a market, there is a potential for setting up these shared lockers. And this could be done by surveying residents to see what is the attitude or the preference of users in terms of, or with respect to using these lockers. And based on that, for example, municipalities can select strategic locations for shared lockers. Another point is the delivery demand data, and I mentioned this earlier that we could not find any demand data The reason could be that private companies, delivery companies, they do not necessarily share their data, but this is something that could, if resolved, could benefit research and therefore public agencies and the society. So if there could be some sort of collaboration, for example, or something that facilitates some information and data sharing between the companies and public agencies, that could certainly be very useful for planning for our cities. And the last point is the curbside implications of increased last mile delivery. So these additional truck routing and truck stopping on the curbside definitely impacts traffic, and how to regulate the curbside and how to value the curbside and allocate different usage to the curbside is something to be studied in future. And Miguel mentioned some of these in his presentation. So at the end, I want to acknowledge FMRI and MnDOT for supporting this research, and also my great PhD student Yufeng Zhang, who did most of this work. And I want to acknowledge City of Minneapolis. We had a lot of conversation with them, and there has been some plans to do field data collection about the last mile package delivery. The activities are unfortunately on hold because of COVID pandemic, but hopefully we can come back together and continue that research. So with that, I'm going to close, and I'm happy to answer any questions.
Thank you, Miguel and Alireza, for this timely and impactful research and presentation. As a reminder, again, for housekeeping, if you have a question, please go ahead and type that into the question and answer field at the bottom of your screen. You might have to scroll over your screen to get that toolbar to appear. At this time, I see some really nice questions that I will hold until we get to the question and answer period. Are there any immediate clarifying questions that folks have for Miguel or Alireza on their presentations? I'm going to give everybody a minute to think about that. And while we do that, I'm going to introduce Andrew Andrusko, again, our MnDOT Freight Planning Director. And Andrew will give us a brief presentation on MnDOT's freight initiatives. Go ahead, Andrew. And Andrew, you are still on mute.
I wanted to thank the Transportation Planning and Economy Council for the opportunity to share a brief update on some of the things that we're working on at MnDOT from the freight side. I think in thinking about that sort of process, we're working on this idea that freight is a continuum. We heard a little bit today about research on the hot and sexy topic of the day, which is definitely e-commerce. And as we think about individual consumer goods, that's definitely where industry is trending towards right now, especially during the COVID-19 pandemic. But as a state government and as a transportation system, we also need to be prepared to have a logical connected system that is able to address bulk goods, oversized, overweight goods that are needed in a short amount of time using different modes. For example, ports and waterways, airports, railroads. And so in thinking about that, I think it's good to set the stage that MnDOT and Minnesota as a state is setting a goal, is setting a target of an integrated system of freight transportation, not just one mode itself. MnDOT is very much a multimodal agency. And so in thinking about that, we want to provide ways to improve on our existing system, as well as ensure the safety, reliability, and competitive access to international markets. That's something that we take very seriously. And in fact, one of the things that MnDOT has done is created a Minnesota Freight Advisory Committee. It's something that we have operated and developed over more than 20 years. And in fact, we were one of the first states to have a Freight Advisory Committee, having established it in 1998. The group includes representatives from many different industries. There are 40 representatives on the MFAC. The Center for Transportation Studies, and in fact, some of the members of the council participate on the MFAC itself. One of the initiatives that we're working on right now is actually renewing the committee itself through a strategic planning effort to talk about what are the issues of the day. Definitely e-commerce is one of them. The COVID-19 pandemic has been a repeated topic of significant interest, but we're also talking about ways that we can work with new groups such as the Governor's Freight Rail Council and others. The group itself advises the commissioner as well as MnDOT itself, and I think at least in terms of that conversation, it really has helped us understand that we need to have investments in our highway system as well as intermodal systems for freight. And it's part of the reason why we developed the competitive Minnesota Highway Freight Program. So that's the second item that I want to talk briefly about today. An initiative that we're in the middle of right now is soliciting and scoring awards on a competitive basis for freight improvements that will help the transportation system across Minnesota. Right now we have our second solicitation. So we had our first solicitation conducted in 2017, and it awarded approximately $100 million. We're up on our second round now, and we have up to $56 million available that we're working with key experts from across the transportation sectors to score and evaluate. And we hope to have announcements for that program and potential awards by the end of the month. So that's something that we're very excited about. Along with that, both the MFAC as well as key stakeholders as part of a freight investment committee are helping us to decide where should we be making those project selections, where are the key areas that we need to be focused on. Earlier I mentioned a freight goal for the state. That goal is reflected in our key investment areas, things that we want to spend those dollars on. And they include freight safety, freight mobility, and first and last mile connections. We look to find projects that improve intermodal connections as well. And occasionally we do some plans and data analysis. One of the things that the current efforts that MnDOT is really focusing on is outreach and public engagement. As we've shifted our approach from a demand-oriented transportation system to an asset management-based system, we are looking for what the public as well as our key stakeholders are looking for in terms of a future system as well, making targeted improvements where we see the greatest value and can relate to issues, particularly for manufacturers. So one area that I also want to sort of touch on briefly is a group of efforts called the Manufacturers Perspective Studies. And this is an effort that MnDOT's Office of Communications and Public Engagement has been leading over the past several years in partnership with the University of Minnesota to understand issues on a one-on-one basis with manufacturers across the state. And the information from the Manufacturers Perspective Studies are being used to make changes in operations as well as propose future investments on the transportation system. So we think that this is a really important effort and something that is really helping us to determine how we can adjust to the new norm that we're facing here today. Along with that, we're looking not just about outreach itself, but also making plans, understanding how to integrate freight within our engineering and planning processes at the operational level as well as in our construction program. So taking the input from those studies and outreach efforts, those one-on-one interviews, we're taking that information and determining key needs that we might be able to integrate into existing projects as well as tie into potential future rounds of the Minnesota Highway Freight Program. That's a competitive solicitation I mentioned earlier. Overall, we intend to use the data as we go out to each region of the state through what we're calling district freight plans to develop and align data needs for our future update to our statewide freight plan, which sets that goal that I mentioned earlier. Ultimately, we are working with our partners both at the federal level as well as the private sector to really get value from these district freight plans and thinking about highway improvements, rail improvements, and other improvements that might be off of MnDOT's transportation system alone. And in thinking about our project selection policy, which is our commitment to being more transparent about how we identify and select projects, we're also using this opportunity to get down to prioritizing those potential freight needs and ranking them to align with those future solicitations I mentioned. A few other areas that we're working on right now that I wanted to share in lieu of our discussions about e-commerce, as well as other trends such as COVID-19. MnDOT is working on a CAVX challenge, which is essentially a challenge that is award-winning, seeking automated vehicle providers and partners that want to demonstrate technology that might be implemented in the future. One of the key arms of the CAVX challenge is the potential idea that perhaps we could get a freight or a trucking partner that has automated vehicle technology that we could demonstrate here in Minnesota. So it's very exciting and something that we really see as being tying into future technology. We're working right now as well, thinking about the current issues of the day, things that aren't necessarily 10 or 20 years into the future, but our current software and data needs for routing oversized, overweights vehicles such as trucks. We have hundreds of loads of deliveries of oversized vehicles and trucks for products such as large windmills. Windmill farms have been an increasing trend over the last 10 years. And in fact, as we look to renewable energy and addressing climate change as a whole, we see this need for oversized, overweight mobility as something that may increase in the future. We're working right now to renew some of the data on our state rail plan, and we see that as something that's very important. There are efforts now to potentially recreate or reassemble the redesignated state rail council, freight rail council, which is sort of the sister committee to the freight advisory committee, and something that we see as very important, especially given the shift towards precision railroading. We're also looking at researching new freight data models, looking at potential options for FAF5 with its ability to disaggregate data on a higher level of information that we had before, as well as looking at potential options from the private sector, potentially to include waybill data from specialists in that area. We're looking at also at ways to support MPO freight planning, and that's something that's completely new that we haven't necessarily talked about in depth in the past. And so right now we're looking for resources both from the FHWA as well as other partners like the FMCSA, MARAD, and others that might be able to help improve MPO freight planning at the regional level beyond MnDOT specific efforts. So these are a few efforts and initiatives that we're working on right now. And I know they don't necessarily directly tie to e-commerce, but I think they would provide a little bit of benefit to the Transportation Planning and Economy Council in that there's a lot of ties to the work of the council and the things that we talked about from our university researchers. I know just looking around, even amongst the panelists, there are folks that are helping us with these efforts from the university and other universities as well. So thank you for the opportunity to share with you some of the key efforts that we're doing, and I'll sort of stand for questions.
Very good. Thank you for everybody. This was a great panel, and we've already got a few questions lined up. The time is 11:20, and I think we're ending at 11:45. So we'll do questions for a few minutes, and then I would like to make sure that we save some time for round robin. As Andrew was mentioning, these CTS Research Council meetings are a really important place for people to share ideas. And so the practitioners and the researchers, we come together here and want to be able to have a round robin so we can keep track of trends that practitioners are seeing and interests that researchers have. So we'll do a few Q&A questions and then try to do some round robin. So think of interesting things that you want to share with the rest of the group in your research. So let's see, the first question we have is from Ken Buckeye. He's asking a little bit about the public costs, the public sector incurs costs to provide the right-of-way for autonomous vehicle package delivery. So what kind of considerations have been made about setting rates that cover at least a portion of the public sector costs? And I think really any of you could answer this question. Andrew, you were talking about the freight plan, and maybe there's some things in the freight plan, or maybe some of the advisory groups have some comments about that. And either Miguel or Alareza has some thoughts about whether that's been discussed. So you can unmute yourself if you want to start talking, and we'll. Oh, Miguel's
I can answer that one.
Okay, great, thank you.
I can try to. I would say that that's a good question, but I don't think that has been, at least what I have seen, that has been considered so far. But I think it's a very important question moving forward, because these are electric vehicles, and obviously the gas tax, it's not using any kind of fuel. So I think that's in terms of paying for the infrastructure, I think that's something bigger, and I think something that must be, I think, consider how and who is going to pay for the right of way and maintenance and so on. The other thing to say is that these are not heavy vehicles. That heavy vehicles tend to do most of the damage in terms of pavement and infrastructure. So I think it's something to consider in that sense, that they are not likely to to create a lot of damage. So those are my 2 cents regarding financing of right of way.
Great, thanks. Andrew, it looks like you're unmuted. Did you have something to add to that?
So I think that that's a really great question. And one thing to consider, at least as we think about the public purpose, if the intent of some of the right of way, particularly sidewalks, is really for public purpose, and the delivery of these goods are for public purpose, just as the railroads were when our government in the United States provided grants to the railroads. Is there a possibility that the right of way would be actually considered a public good that we're providing to the private sector as economic development?
Hey, Lisa, I'm gonna sort of take us in or maybe take co-moderator prerogative here. And we have a couple of folks from the city of Minneapolis, both Jenny Hager and Danielle Elkins. And I know that they are looking at sort of curbside management and rights of way as it relates to the use of the curb space. And I'm wondering if either one of them would be willing to maybe share a couple comments about how the city of Minneapolis is looking at this. And let's see, maybe the easiest thing is, if Jenny, I'm gonna unmute you, and if you'd be willing to chat, or if you want to throw it over to Danielle, let me know, and I can unmute her as well. So I'm unmuting you, Jenny, I think. Let's see, Jenny. Oh, unmute. There we go. No. Let's see, Jenny, if you maybe unmute on your end, try that.
And maybe she stepped away. Oh, there she goes.
I'm sorry. Yep, I stepped away for 1 second. Can you repeat the question?
Yeah, Jenny, I was just wondering if we had a question related to sort of curb space as it relate, and paying for sort of that use. And I'm just curious as to what is, how is the city of Minneapolis thinking about curb management and curb right of way and things like that as it relates to package delivery?
Oh, right. Yes, that is top of mind for us right now, and something that we're actively working on. So one of the first priorities that we're trying to do is actually to inventory our curb space, so we have a good understanding of how it's being used right now, how it's signed, and where the uses are currently along the curb right now. That's a data set that a lot of cities are trying to undertake and get a handle on across the country right now. And of course, it's very dynamic. So right now we're trying to get that into our GIS system so that we can actually see throughout the day how the use of the curb is changing. So that's step number one. And then right now we're actually starting to meet with stakeholders and develop what would be more of a curbside policy or curb management policy, so that we can be more proactive about managing our curb. So right now it's a very reactive form of curb management where you sign the curb and then you try to enforce how that signage is out there. And we're going to try and move to a more proactive way of managing that curb. But we're not quite there yet. We're trying to develop what those policy statements might look like, and then what is more difficult is how you actually implement that when it comes forward. And one of the main challenges there is just the use of terminology and everyone's different understanding of all the different terminology that's being tossed out there for the different uses at the curb and then the curb itself. So that's kind of where we're at right now in the process.
Well, great, thanks, Jenny, and great answer for me putting you on the spot. So, but I thought it was important to hear your perspective. So thanks so much.
And I have a comment or question related to the funding of things too. I'm curious if developers are starting to take an interest in looking at infrastructure, whether it's the right of way for robots to travel or putting lockers in. And this could be small to large, an apartment complex or a condominium complex could put an easy place to drop things off in their building. But larger developments like the Ford plant here in St. Paul, if they're thinking about that ahead of time, they could build that in as they're developing that whole area. So I don't know if any of you have any examples of where developers may be starting to take an interest in automated deliveries. No. And that's fine.
So this is Andrew. One of the things that we have heard interest in, and maybe this goes back to the point about equity, is there's an increasing trend for having Amazon package delivery rooms on larger mansion-size homes, particularly for the rich and celebrities. And so, in thinking about that space is attached to private homes and could interface with automated delivery robots in the future. So in some ways, this COVID-19 is perhaps accelerating that trend, at least in terms of the sort of the rich and famous in getting those types of deliveries.
Thanks, Andrew. And that's a good comment about some of the equity issues. I know Miguel, I think you mentioned that you're seeing some benefits of package delivery that's across the board with all people, but I'm wondering what additional research is being done to make sure that automated package delivery like this is really equitable for all folks. Either Miguel or Alvarez, are you familiar with any? Are you aware of any research that's being done more in depth on equity, especially with racial disparities?
As far as I'm aware, I haven't seen any. I think we are the first trying to tackle this issue of equity and home deliveries and e-commerce. And what we have seen is there is a big very different delivery rates and type of services by income and neighborhood. So, but again, it's preliminary, so we don't have anything to share in terms of a paper or report, but that's what we're seeing.
Thank you. So we have another question in the Q&A. This one's an anonymous attendee. So it says, for lockers, what about in rural areas where the driving distance are much farther and the delivery drivers are a large % of the cost of delivery? And then is there an extension of research that could incorporate the U.S. Postal Service to use, to be used for that kind of delivery, so it helps support the post office?
Yeah, I think this is a great question, and this is kind of one of the underlying questions in this research, that what are the most suitable areas for having these shared lockers? Where do we get the most efficiency from these shared lockers? But at this point, I think it's hard to answer or give any general comments about whether it works better in rural areas or in denser area. We had some preliminary testing on different networks, denser network and sparser networks. And what we got in the results was that when we have a denser network, higher density customer demand, we have a greater efficiency gain. So again, I cannot generalize it because we have not calibrated the models fully yet. There are a few data limitations. But at this point, I think the preliminary finding is that because of the longer driving distances, it might not necessarily work as well in sparser areas. And another thing that we want to keep in mind is that besides the distance and operating costs, there are other factors that can affect the efficiency of these lockers. For example, the foot traffic, the accessibility for different people, and there may be some really strategic locations that work best for these shared lockers. So for now, we know that Amazon is setting up these lockers mostly in Whole Food stores, but also locations such as transit hubs with greater foot traffic, or park and ride locations in the suburb could potentially be some good locations for shared lockers. As far as research about USPS and funding, I'm not aware of any research on that, and I don't think we are working on it in the near future.
Great. Well, we have a related question or a related offer to chat a little bit about locations of hubs, not in rural areas, but I think it's related to some of what you were just saying about where to put lockers. So Danielle from the city of Minneapolis has some thoughts about having package delivery at mobility hubs and parking garages, and you mentioned park and rides and things like that, Alareza. So we'll unmute Danielle and let her add a few things. I was curious about this as well too, thinking about these locations, because before COVID, parking garages would have been a great place for package pickup, because people go to work and then they can pick up their, they're not making a separate driving trip to go to their locker. The locker is right where they've parked their car for work, and they can pick up their package. It hasn't been stolen off of their porch. But post-COVID now, the locker locations might be different. But interested to hear what you're thinking about, Danielle, with these mobility hubs.
Yeah, there's kind of two parts. So there's the parking garage situation. So we are piloting putting Amazon lockers in some of our city-owned parking garages. And Lisa, you're familiar with some of the challenges that we have about turning some of these facilities into mobility hubs and having the restrictions of commercial activity in these spaces. So also trying to change that, hopefully at the state level. And then we're also, we've really been pivoting our mobility hub pilot throughout the summer, looking at food access and resource access at these public central locations. So we are piloting a small locker concept at our mobility hubs to give people potential pickup options, with the idea that in the future, this network of regional mobility hubs would include some kind of a locker and package system that allow people to eliminate trips on the way home. And it could be, your DoorDash driver puts your meal in there, your groceries are put in there, or just your regular Amazon package for those that do have those security or neighborhood access issues, that could potentially solve it and have a public benefit. A lot of the locker systems that currently exist in the city of Minneapolis are actually for, if they're not Amazon, they're for dry cleaning, which serves a very different market, but the lockers themselves could be used anywhere for anything.
Great. And Danielle, it sounds like some of the locations and the thoughts about the lockers in your study do address some of those equity issues. Can you comment a little bit more about that?
Yeah, so our mobility hub pilot is focused on locations within the ACP 50 areas primarily. So this is directly looking at that situation. And for those neighborhoods, it was making sure that there were locations near grocery stores or libraries or human service centers, and that there were ways for folks to be able to access the different services, especially during times of COVID where it's safer to be outside, to be doing donation distribution or food distribution, having these kind of key neighborhood access points that people know they can go there to get resources, but also transportation access, but also potentially freight and goods access.
And I would guess even prescriptions could be dropped off at a locker, so could provide better access to
these smaller lockers that we're doing piloting. That's actually one of the main uses that people use them for.
Great. Well, I'm glad to hear a little response to some of the equity discussions, because I think we all have that in mind, that anything we're doing going forward, how are we making sure that it's benefiting everyone, or who does it benefit and who doesn't it, as opposed to Andrew's example of the mansions with delivery spots. We've got two extremes then of where some of this delivery is benefiting folks. All right, so we have another question in the chat. So Elliot McFadden is writing about teleoperations. So that's not something I'm familiar with. Hopefully one of our presenters knows what that is. Evidently there was a bill that FedEx was introducing. So the question is, where does the industry push for teleoperations as opposed to true automation fit in the freight investment? So if anyone understands the teleoperations and can comment on that, Andrew or Alariza or Miguel?
I can also unmute Elliot, and maybe if he wants to share a little bit more about maybe be more explicit about what his question is.
Thank you.
There we go.
Yeah, thank you. Yeah, the question is, there's a lot of discussion about autonomous vehicles, but it seems like there's also quite a bit of movement in teleoperated vehicles. So vehicles that are not truly autonomous, but are actually being operated essentially like a drone, but a drone on 4 or 6 wheels. That seems to be much more attainable and immediately deployable versus truly autonomous vehicles. And FedEx had a bill this spring at the legislature where they were trying to get the regulatory and legislative kind of ducks in a row to be able to test that kind of equipment. And we're seeing that both in micromobility with scooters and also with delivery vehicles in other parts of the country. So I wanted to see if there had been any thought in the freight discussion at MnDOT or on the academic side about how that could be deployed and where people were going with that.
So Alariza, I know you had a couple of pictures of different vehicle, or no, was that Miguel? Yeah, Miguel, you in your first presentation you had an assessment of the different vehicles, and you had a picture of the FedEx one. Is that one that was teleoperated? And do you have any more detail on?
Yeah, as far as I know, they're all teleoperated and they're all monitored and supervised. So all these deployments, especially because they're still in the kind of testing phase. So there are companies that are collecting a lot of data, and I think they're still trying to solve many of the day-to-day challenges in terms of how to navigate, roads and sidewalks. So they do have, supervision, constant supervision in terms of how these vehicles are moving and where they are and so on. So they are not truly autonomous in the sense that, it's just artificial intelligence just doing everything. There is always someone there in case there is a problem.
That makes a lot of sense, and especially navigating sidewalks with dogs and kids and balls and people walking and rolling, and it would make a lot of sense that they're teleoperated and someone's actually driving the vehicle from afar. Great, thanks. So we have another question from Wendell, and I think this will be the last question we take, so we've got at least a couple minutes for round robin. So it says, within the completed research for autonomous vehicles, the example, the robots, what are the critical elements or factors that drive private sector deployments? Cost, efficiency, or environment, or others? So I think one of you had some slides on the cost benefits for deploying this. So can you talk a little bit more about what would be that turning point when a delivery company would invest in some of these robots? And I guess that relates a little bit to another question I had too, with, like, what are, maybe the way to ask it is like, what's the perfect scenario? Is it a campus, either a college campus or a business campus? What are some of the places where it makes most sense to deploy this kind of thing?
So I can just say that I think regulation is a key issue, and there are cities like San Francisco, for example, where there are so many startups and technology companies where neighbors and city authorities are very worried about having too many test vehicles moving around, so they are more restrictive. So they move to states like Arizona or Phoenix, where there are more. They have less rules and regulations. So I think that's one of the key issues in terms of being allowed to operate and test. And the other thing is, you mentioned college campuses, of course, having a population either, like you was mentioned, in terms of having enough income or being young and familiar with technology, that would be okay with this type of deployment. That's what I can say based on the type of deployments. It's universities, obviously before COVID had the advantage of having a large population in a very dense, small area that it's somewhat confined and easier to map and navigate compared to the challenges you could find just when you move to any type of street or any type of roadway.
Well, this was a great Q&A session. I think we've had some good discussion. I've got more questions, but I think we need to cut them off and open it up for round robin a little bit. And as a reminder, this is a presentation on freight, but it's also our CTS Research Council meeting on planning, transportation planning, and the economy. So if anyone has any updates on what you're doing with planning or the economy in your organizations, or any research ideas you'd like to bring forward, now is the time to share in round robin. So Elliot has an update. I'll just read this here, and then if we want, we can unmute Elliot to answer any additional questions. I'd like to share that MnDOT's Office of Transit and Active Transportation received an FTA innovation grant to build a regional mobility as a service platform in southern Minnesota around Rochester and Mankato. The platform will allow trip planning, payment, and trip tracking for transit and shared mobility providers in the area. Historic trip data and platform search data will be used as a planning tool to identify gaps in service and community needs. We will be developing the platform in 2021 with an early 2022 launch date. So I'm assuming that's an app then, where people can schedule rides. It looks like, Elliot, you're unmuted, so if you want to say a little bit more about that.
Yes, there will be an app that'll be involved, but we're actually building a whole ecosystem behind the app that will allow this kind of functionality to be usable on all sorts of apps. We're going to take a very open architecture approach and implement data standards so that whether it's the MnDOT app or Uber or Metro Transit app or any other transportation app that wants to serve the area can plug in and get this sort of functionality. And then from the planning perspective, we'll be also building a planning tool that will allow local and regional planners to view historic information and search data from trips that people are trying to find connections on, so that we can better see where we have gaps and where we need to bring in new services.
Great, thank you. Well, we'll look forward to hearing more about that. All right, it looks like we're 2 minutes past time, so Ken is just sharing one thing, and then I guess we'll have to, stop the sharing. MnDOT is progressing in our car sharing demonstration that is testing the platform as a potential efficient fee collection mechanism that might one day supplement or replace the gas tax. Oh, that's fantastic. So yeah, the car sharing demonstration with fees for the mileage is a good test for that type of fee collection. And if that works, he's saying that could influence the transportation funding that's currently gas tax. So fantastic.
Well, and Lisa, I just want to mention real quickly that both the projects that Elliot mentioned and that Ken is talking about have research components. So I think there's opportunities in the future to have presentations more on, some more on these projects as they get further along.
Perfect. Oh, that's great. I was thinking that as Elliot was giving his, I was like, I wonder if we can present that, but I'm glad for sure that it's got a research component. So we will be able to have a session on that in the future. Great. Well, thanks everybody for participating in the Zoom version of a council meeting. It's a little different. It's harder to share, I think, but I think we managed it well. And thanks everybody, and hope to see you at the next Research Council meeting and at the CTS annual meeting, or the annual conference coming up in November. So thank you. Any other final words, Gina or Katie or Mary?
I think we're good. Thanks, everybody.
Take care, everybody.
Thank you.